Okay, I'm back, and now it's time to study lesson number 16 for the Unit 2 lecture exam. So this one is on superposition of waves. So remember to read the lesson objective to find out what's going to be on the exam. And then this is Chapter 20, Sections 1 and 2, Chapter 20, Sections 7 and 8, Chapter 20, Sections 1 through 5. All right, this shows how to add waves together if you have a ruler. So that you have wave A and wave B, and you're going to add them together by adding their amplitudes together at different times. So this is time that is going sideways, and then you're going to have wave A, but let's say it's doing that, and then underneath it you're going to have wave number B, which, just say for the sake of argument, is doing something like this. Then what you would do is you're going to need to have a ruler, and you're going to need to pick out a spot at the same distance from the origin here, and then measure that distance up, and then this one is going down. So it's going to be this distance, which is a positive number, and then you're adding it to this distance, which is a negative number, so you're subtracting them. And whatever that number is, then you put it right underneath it. And then you go over to here, and then you repeat it. So the closer you get your measurements, the more accurate it's going to be when you add them together. So if this is on the exam, it's going to be a bonus question. And I would save this one until the end of the exam, because it's going to take you a while to manually do that. It's not difficult, but it is time consuming. Okay, then we talked about adding waves together in a certain way. If the two waves are identical, so that means that they're going to have the same amplitude and they're going to have the same frequency, which is to say that they're going to have the same wavelength. So if we add these two waves together, we can get constructive and destructive interference. So let's take a look at constructive interference for transverse waves. So in that case, you're going to have a wave that's like this, and we're going to superimpose on top of it another wave that is absolutely identical to it. So it has the same amplitude as the original wave, and it has the same wavelength as the original wave. And notice that when this one is cresting, this one's cresting. When this one has a trough, this one has a trough. So when you put them together, you get an extra big wave. Notice that the new wave has the same frequency, and it has the same wavelength as the original waves. What has changed? The amplitude. So the amplitude is extra large. So that's going to be called constructive interference. You should be able to make those pictures for the exam. Okay, then you have destructive interference, and so we're going to take this wave here, but we're going to add it to a wave that is opposite in every way. So we're going to add it. Let me see if I can, where can I put it? Let me put it up here. All right, so let's say that I add it to a wave that is going down when this one's going up. And then when this one's going down, this one's going up. And then when this one's up, then this one is down. So we're going to add those two waves together, and this time they cancel out so that we get nothing when we add these two waves together. So that's going to be destructive interference. Now I put off to the side there a similar looking picture about adding sound waves together. So this was transverse waves, and an example of a transverse wave was light waves. Sound waves are longitudinal, but I just wanted to show you that you can add sound waves together and get constructive interference, and you can also add them together and get destructive interference. So be able to do it for transverse waves. Another thing I'd like for you to know is that constructive interference occurs when they are in phase. We'll talk more about this later. Okay, and then destructive interference is going to occur when they are out of phase. Know how noise canceling headphones work under the principle of destructive interference. Okay, you can also add two waves together that have different wavelengths and they have different amplitudes. And so that's what this is showing. And there are two kinds of radio signals, AM radio signals and FM radio signals. I just wanted to show it to you so that you can see what it is. Having done that, don't worry about it. This is not going to be on the exam. Okay, standing waves, yes. Okay, so there's going to be some bonus questions about standing waves. And one thing about a standing wave is it has nodes and antinodes. So where the wave, the standing wave, has its maximum amplitude, that's going to be an antinode. And then where it has minimum amplitude, that's going to be a node. So in this picture here, if I turn this thing into a standing wave like that, then this right there, that's a node, and then this right here, that's a node, and then halfway in between the two nodes is going to be the antinode. So just know the definition of what a node and an antinode are. Okay, and then there are different ways of producing standing waves. So one way of doing it is to have a string that is attached to a wall on both sides, and then you pluck the string. And so that's illustrated in the far right-hand series of pictures. But you could also have a straw. So in the case of a straw, you could close off one end of the straw and then blow across the open end. And then that would be the middle picture. Or you could leave your finger off the end of the straw and blow across the top of it. And that's the pictures that are over there on the left-hand side. And so you can see that you can have different standing waves set up in each case. And there is a relationship between the distance in meters from a node to a node. And so that's going to be equal to the wavelength of the wave divided by 2. And then there's a relationship between the distance from a node to an antinode, and that's going to be the wavelength divided by 4. So here's a sample question that could be on the exam, and it would be bonus. So being able to figure out where the nodes and the antinodes are and then calculate the wavelength of it. All right, know for the exam what the word loudness means and how is it related to the amplitude, and then also know what pitch is and how is it related to the frequency. You're not going to have to know about quality. Okay, then we have musical instruments. So could you tell me the 3 major kinds of musical instruments? So you have string instruments, wind instruments, and then percussion, like a drum. And so this would be bonus on the exam. Having a guitar and then strumming it, and then figuring out the frequency of the sound that is being emitted. Okay, and so that's illustrated in this question right here. And then this one is, what about if you've got a jug or a straw and you blow across the top of it? What's the sound that it's going to produce? So again, there's an example of it. This is not going to be on the exam, but it shows you the different frequencies of a piano. This is going to be on the exam. So knowing the different parts of the human ear and then what do they do. So you need to know 5. You need to know 5 different parts of the ear and then what do they do. So let's start with the outer part of the ear, which is going to be the pinna, and it's a funnel. So it collects the sound and funnels it into the ear canal. So that's going to be our next, so now we're up to 2. So the ear canal is for protection. Then the third one is the ear drum. And so what that does is it's going to take the sound waves and turn them into a vibration in your ear. Okay, then on the other side of that is going to be the bones. So there are actually 3 bones, and so this is the fourth part of the ear, and it's going to be the 3 bones. Their purpose is to amplify sound or to protect the ear if the sound is too great. Okay, number 5. So number 5 is going to be the cochlea. And so that's that snail looking thing. And in that snail thing is going to have these hairs that are going to be vibrating. So as the vibrations go through the ear, it's going to cause these hairs to begin to vibrate. And each hair goes with a different frequency of sound. And then as it vibrates, it's going to make electricity. And then the electricity is going to go down the auditory nerve to the brain. Okay, and then there's some other things that you can mention. So the eustachian tube that helps to equalize the pressure on either side of the eardrum. And then the semicircular canals are the things, they're like 3 loops. So you got one loop like this, you got another loop like this, and then you got another loop that's like this. And so the purpose of those loops is it tells you the orientation of your head, whether it's to the right, to the left, up, down, or turning right, or like that. Okay? So be able to give me 5 different parts of the ear, and then what do they do. So that completes this lesson. So let's take a break. We're halfway finished, and when we come back, we're going to start talking about light.